Today, I'm going to show you how to determine the equation of a parabola in vertex form. Remember that vertex form looks like this, with the a bracket x minus h squared plus k. Also remember that hk is the vertex. So that would mean that the first step to determining the equation is to determine the vertex. So in this first example, the vertex is at 2, -4. So that means the h is equal to 2 and the k is equal to -4. So when we go to write our equation, you're going to put the 2 in for the h and the -4 in for the k. So the h is 2. And the k is -4. The next thing you want to do is determine the a. And really all you need is to look at the steps if possible. Sometimes you can't determine from the steps because it could be a fraction or a decimal. But if you take a look at the steps, the first step is over 1 up 3. So the first step is supposed to be over 1 up 1. Here it's over 1 up 3. So that means your value of a is equal to 3. So your first step is equal to a. And that's enough for your equation. So your a value is 3. Your h value is 2. And your k value is -4. And there is your equation in vertex form. Now that would be a knowledge question. An application question would be more like this one, where you can't easily determine the steps because here's the vertex. And if you move over 1, it's hard to tell how high up that goes. It looks like it goes up a half, but who knows if it goes up a half or if it goes up a third or if it goes up 0.4. You can't tell exactly what the first step is. So this is what you have to do in this example. First step again is to determine the vertex. So the vertex here is at 5, 0. So the h is 5 and the k is 0. That goes into the equation. And of course, you don't need to write the 0. Now, in this case, in order to determine the a value, what you're going to do is find any other point on the graph. We can use this one. And this point is at 3, 2. What you're going to do with this is substitute this 3 in for x and the 2 in for y so that you can solve for the a. So the 2 goes in for the y, which of course is the same as f of x. The 3 goes in for the x. And we don't need to write the +0. And we're going to solve that equation for a. So the first thing you're going to do is the bracket. 3 minus 5 is -2. You're going to do BEDMAS as much as you can. Negative 2 squared is 4. And then now you can solve for a. Because that's a times 4, what you're going to do is divide both sides by 4 so that the 4's can cancel out. So a is equal to 2 over 4, which is 1/2 in lowest terms. So your equation is 1/2 x minus 5 squared, and the k is plus 0, which we don't have to write. So we'll try one more. Here's the vertex at 4, negative 2. So this is the h value, and this is the k value. So the vertex is at 4, negative 2. So that goes into the equation. Again, pick any point on the parabola that is not the vertex. So we can pick this one, which is at 1, 1. And those values go in for x and y. So the y, which is the same as the f of x, is equal to 1. The x, which is also 1. Now you're going to use bedmass as far as you can. So the brackets, 1 minus 4 is negative 3. And negative 3 squared is 9. Now we can't do bedmass any further. Some people think we can take this 9 and subtract 2. But we can't take the 9 and subtract 2 because this 9 is being multiplied by a. So this 9 times a is not like terms with this negative 2. So now we switch to solving the equation. So what we'll do is we will add 2 to both sides. And then divide both sides by 9 for that to cancel out. So that means a is equal to 3 over 9, which is 1/3 in lowest terms. So your equation is 1/3 x minus 4 squared minus 2. And that's how you determine the equation in vertex form. Determining the equation when you have a word problem works the exact same way. You have to determine what the vertex is, and then you have to determine what another point is on the line and substitute it in. It works exactly the same way. So the relationship between the selling price of a bag of cotton candy, S, and the daily profit, P, of a cotton candy vendor at the fair is illustrated in the following table. What we're going to do is sketch this relationship down here, and we're going to determine the equation in vertex form. So to sketch it means we don't have to plot all the points. We can plot a few of them. We know at 0, profit is down at negative 80. So that's at negative 80. 0, negative 80. And we know that the vertex is going to be the highest point, which is right here, so we can plot that one. That's going to be around 160. That's the vertex. So it's going to look something like this. No. It's going to look something like this. We don't know exactly when or where it crosses the x-axis. That's okay. This point here, we're back down at negative 80 at the point 4, negative 80. So it doesn't matter where it crosses the x-axis because all you need is the vertex and one other point. We have the vertex, and we know that's the vertex because that's the highest point. And not only do we have one other point, we have several other points. But this is a nice, easy one to use. So what we're going to do is we're going to substitute this in for the vertex. So this is your h value and this is your k value. So instead of using f of x, we're going to be using p of s. Because instead of the y, it's p, and instead of the x, it's s. Equals. We don't know what the a value is, but we know that the x value is 2. And we know that the k value is 160. Now you take any other point, like this one, 0 and negative 80, and you substitute that in for x and y, or in this case, p and s. So this is s. This is s and this is p. So the negative 80 goes in for the p of s. And the 0 goes in for the x. Use bedmass as much as you can. So in the brackets, 0 minus 2 is negative 2. And now exponents, negative 2 squared is 4. And you cannot add these because this is attached to the a. So this is like 4a, and it's not like terms with this. So now we switch to solving. You're going to subtract 160 from both sides, which is going to make this negative 240. And then divide both sides by 4. That makes that negative 60. So your a value is negative 60, and there's your equation. P of s equals, the a value is negative 60, the h value is 2, and the k value is 160. Now, interestingly enough, you actually could have determined the a value from the step pattern. So if your vertex is at 260, if you go over 1, not over half, but if you go over 1, so if we went to 1, if we went over 1, we got to this point. So over 1, we would have gone from 160 down to 100. So that means we would have gone down 60. So that would have told you that your a value is equal to negative 60. So you could have done it that way as well. Now there would be another word problem where they're not going to give you any of the points. You need to figure it out from the word problem. So in this example, a park has a parabolic arch at the entrance. The arch spans a total of 22 meters and is 20 meters high in the middle. So your arch would look something like this. Doesn't have to look perfect. And it spans 22 meters. And it is 20 meters high. It's 20 meters high at the middle. So that would make the vertex at 1120. And the reason it's 11 is because that vertex, the center, the highest part of the arch, the maximum, is going to be halfway along the span of the arch. So half of 22 is 11. So the vertex is going to be halfway along the span at 11 with a height of 20. So the vertex is at 1120. So that's going to go in for the vertex. And it doesn't say what letters we have to use, so we can use f of x. And to get the other point, probably the easiest one to use as the other point would just be right here at 0, 0. So you'd substitute 0 in for x and 0 in for y. But for y, we're using f of x. And we'll solve that. So 0 minus 11 is negative 11. Negative 11 squared is 121. Can't add these. So now we're going to solve for a. I'm running out of space, so I'm just going to move it over here. Subtract 20 from both sides. And then divide both sides by 121. So that makes a equal to negative 20 over 121. And what you're going to do is to leave your a as a fraction. Don't change your a to a decimal. So that makes your final equation f of x equal to your a value of negative 20 over 121, x minus 11 squared, plus 20. So doing this as a word problem is the same as doing it without a word problem. It's just that you have to draw the picture first and determine the vertex and any other point on the line. Sometimes you're going to get word problems, and you're going to have to use the information from the word problems once again to determine the vertex. So this is an example of a parabola in real life. You can see this, it's kind of taken from its side, so it's a little hard to see. Here is a better picture of what this bridge looks like. This is the New River Gorge Bridge in Fayetteville, West Virginia. It is the world's longest single arch span bridge. So it's the longest bridge that has only one arch supporting it. This picture I took on my way down to Myrtle Beach on vacation. It is the second highest vehicular, so it's for vehicles, bridge in the world. Now, the following diagram illustrates some data about the arch. So it spans here 1,700 feet squared, and from where it attaches into the ground, the height of the arch is 360 feet. So what we're going to do is to determine the equation of this in vertex form, which could model the arch. And we're going to leave our a value as a fraction. So there's two things you can do. You can make your arch look like this, where the vertex is on the x-axis, or you can make your arch look like this, where your vertex is not on the x-axis. It is easiest if you make your arch look like this, where the vertex is on the x-axis. So that's what we're going to do. So we know that the span from here to here is 1,700 feet squared, which would make this point at 850 and 0, because 850 is half of 1,700. And the vertex is on the y-axis, so the x-coordinate is 0, and the y-coordinate is 360. That's the vertex. So the h is 0, and the k is 360. When you go to substitute this into the equation, the x is 0, and the k is 360. And since we really don't need to write the 0 for the, since we really don't need to write the 0 for the h, we can just write it like this: ax squared plus 360. So it's a little bit easier if you put your vertex on the y-axis versus putting it not on the y-axis, because then you'd have an h value and it's a little bit more work. Now you take any other point on the graph, which would be this one, and substitute that in for x and y. So the 0 goes in for the y, and the 850 goes in for the x. Use BEDMAS as much as you can. So the first thing we have to do is square that 850. And that is 722,500. Once again, you cannot add these two because this is attached to the a, which means this and this are not like terms. So now we switch to solving for a. So you're going to subtract 360 from both sides. And to get a by itself, now we're going to divide both sides by 722,500. So that those can cancel out. And when you put that fraction into lowest terms, it works out to negative 18 over 36,125. So you can get lowest terms just using the fraction calculator on your button. And it says to leave your a as a fraction. So this is your equation. Your a is negative 18 over 36,125 x squared plus 360. So, and a word problem is going to end up looking exactly the same as we did in the previous page.